Good morning. We are going to see the solution of day 4. Up to day 3 I have already uploaded. Now we will go with day 4. The steel rod 18 diameter is to bend to a circular arc. Find the minimum radius of curvature. So I already mentioned you. So we are in this fashion. We have this is 16 mm diameter bar. And then we have r radius of the curvature. So we have till end, till this. So if I will consider this cross section 16 millimeter diameter, I will draw enlarge. So we have like this. And stress is given not exceed 120. If we will draw bending stress diagram for this, so we are been in this. And this is given 120. Still diameter is given 16. So we have this as 8. And below also we have 8 millimeters. So we have formula, flexure formula, we have m by I is equal to sigma by y is equal to E by R. Here we are interested with the radius of curvature. Sigma is given, so we have to use this part. So we have sigma by y is equal to E by R, or we can write R that is equal to E by sigma into y. E is given 200 into 10 raised to 3. Y is 8 upon maximum stress is given, bending stress 120. And calculating this value, we are going to get value of R that is equal to 13.33 into 10 raised to 3 millimeter. So just check it, just I will check. Yes. So we have this value that is equal to 13.33 into 10 raised to 3 millimeter. So 13.33 into 10 raised to 3 millimeters. Or we can write R equal to 13.33 meters. So we have to solve problems related with your radius of curvature in this fashion. So now the cross section of a simply supported beam of span is shown in figure. The permissible stresses are 100 in compression. So keep in mind, so you have two diagrams are given. So one is given 100 MPa in compression. Simply supported is given. So it is 100 and below we do not know value. It is not 40 below, keep in mind. And another permissible value is given 40 below. What is value at top we do not know. So we have this will be sigma T as 40. This is tension. This we do not know. Sigma T. We do not know. Sigma C over here. Now we have to check by using this, what will be my moment of resistance? By using this, what will be my moment of resistance? And minimum of the two will be considered as moment of resistance. Keep in mind, not maximum, minimum of MR due to compression and MR due to tension. So now we have to first find I. So we will go with Y bar, that is equal to summation AY bar upon summation A. You have to write formula. Examination, it is most important. summation ay bar upon summation a. And then we have y bar that is equal to 100 into 25 into 25 by 2 plus, so from center of this, so we have 25 by 2 from this center, so we have this as 150 and then 25 this total 175, so we have 25 into 300 and that will be 175 plus last 200 into 75 into, now from bottom of this, so or from center of this, so we have 325 and this will be 75 by 2, so that will be 37.5, so we have 325 plus 37.5 and divided by area. So area we have to consider 100 into 25 plus 25 into 300 plus plus 200 into 75. So this is first 125, 325 and then 275, and this will give me value of y bar as 271.25 millimeters. So 271.25 millimeter. Now you are now too good with so we have IXX, ICG plus A into H square. Now we will go first, top flange, B is 100, D cube 25 cube by 12 plus, now you know AH square 100 into 25 area, H we have 271.25 minus this value that is of y1 12.5 whole square plus we have another web, second part 25 into 300 cube by 12 plus A into H square 25 into 300 into, now we have to consider y2 175, so we have 271.25 minus 175 whole square plus third part we have B as 200 into 75 cube by 12 plus 200 into 75 into, now we will get this as 325, 350, so 0.5, 362.5, so this value, and therefore we have 362.5 minus 271.25 whole square, and solving this we have value of I got 425.17 into 10 raised to 6 millimeter to the power 4. Now we know value of y bar. So if we will consider y bar, so we have 271.25. So if we will calculate bottom value, so we have this value, total we have 400. So we have 400 minus 271.25. So we will get this value that is equal to 400 minus 271.25. So we have 128.75. So we have this value 128.75. So this is YC and this will be YT. Now we will go with, we have M by I is equal to sigma by Y. Now this M we should have less than or equal to MR. So we have to find MR. So let us, we will say equal. So MR compression equal to I, we have same for both. So sigma compression upon Y compression. And we will put it, therefore, MR compression equal to sigma C, that is given for compression as 100 into value of I, we have 425.17 into 10 raised to 6, and value of Y we have 271.25 for compression. And from this we got value that is equal to 156.74 into 10 raised to 6 Newton millimeter, or we can write MRC equal to 156.74 kilonewton meter. In exam, sometimes they may ask, calculate moment of resistance of this section. Then we have now MR in tension upon I equal to sigma in tension upon Y in tension. And we have MR tension that is equal to sigma T is 40, I is 425.17 into 10 raised to 6 divided by 128.75. And if you calculate this value, we will have this value 132.09 into 10 raised to 6 Newton millimeter. And therefore we have MR in tension as 132.09 kilonewton meter. And therefore MR of section minimum of 2, MR of section equal to minimum of 1 and 2. So this is 1 and this is 2, and therefore MR equal to 132.09 kilonewton meter. And now we have given span of 5 meters. So we have span of 5 meters. So we have this as 5 meters. And UDL, let us, we will consider, we are interested to find UDL. So we have, let us, this UDL W on this. And therefore we will get M is equal to WL square by 8. Now W into 25 upon 8. And we know this is equal to M, which is equal to 132.09. And from this we will get W is equal to 132.09 upon 25 into 8, and that is equal to 42.27 kilonewton meter. And safe UDL, we can say safe UDL equal to 42.27 kilonewton per meter. So from this I covered two parts. One, determine safe UDL, and second part, to find moment of resistance of this section, which is minimum of compression and tension. So now we will stop here only. This is your first part of the day 4 exercise. So thank you.